So in this video, we're going to explore data visualization using ggplot2. All right, so what is ggplot2? ggplot2 is a very powerful and flexible R package. In fact, it's actually part of the tidyverse framework for producing elegant graphics. Originally, it was developed by Leland Wilkinson and further adapted by Hadley Wickman. Okay. In fact, ggplot, the GG here stands for the grammar of graphics. Okay. Basically, which describe plots by using a grammar. Okay. The best way actually to use this package is by installing the tidyverse package here, or you can alternatively install individually. By calling it ggplot2 here. Okay. So yeah, let's go through the tutorial now. So I'm going to use this very wonderful tutorial. Part of this, comes from Bradley Boemike and Hadley Wickman. Okay. All right. So there are different components that I'm going to go through here. The ggplot. So we're going to look at the data being plotted. Yeah, these are some of the features, some of the things we're going to look at today. The geometric object, that means, the circles, the lines that appear on the plot. Okay. The aesthetics, statistical transformations, after you projected that on your geometric objects, you can get the count or data values used in that plot. Position adjustment, right? We can expand on the different options available for geometric objects, right? Then the scale here for the aesthetic mapping, we can, override the default settings and, specify a range of values. Coordinate system, okay? This is also a method for, organizing geometric objects. And lastly, we can also decide to show different subsets or different subplots, right? By using a categorical variable, and this we can implement using facets. Okay, so Wickman, was very instrumental in adding these different concepts that we can visualize ggplot in terms of layers, right? Not only layers, we can add different layers on top of a ggplot, canvas here. Okay. All right, let's get started. So the basic idea here, the intuition here with ggplot is that we have three important components, right? So at the very top, we use this method, ggplot, right? And then we pass different arguments, right? So by default, ggplot function creates an empty canvas like here. Okay, and then we use the aesthetic mappings here. The aesthetics here, we use that to indicate the X and Y variables, right? And we can also have much more control on how we want to display the color, the size, and the shape for aesthetics, right? And lastly, we can decide, okay, so once we have our variables that we want to display, right? How do we represent our data points, right? So we kind of we add a new layer in form of geometric objects, and we can specify, do we want to use, so basically we're just going to be geom underscore, and then we can specify whether it's a point, whether it's a box plot, and things of that nature, right? We're going to look at that, bit by bit. Okay. So ggplot comes with an inbuilt data set. We're going to use the MPG, right? So let's go over that real quick. So this we're going to implement these different code chunks. So let's do that. So I'm just going to quickly go here. So by now the assumption is that you already have installed tidyverse. If you don't have, just can comment that, and you can run that, comment it back. And then we can load our library, right? And we can view our data set, right? As you can see here, MPG is part of the ggplot package, and we can read a little bit more about this data set, right? We can also view, you can just say view MPG here, and it's gonna pop up a window in an Excel sort of format, right? In a very nice, rendered in a nice table, okay? So, but of importance here is also to look at, our data set here, right? We can use the structure here, structure method, just to look at the data types for variables, right? As you can see here, we have a mix of numbers, integers, and characters, right? Yeah, and we can read a little bit more about that, okay? All right, so the next thing we want to do is to create, you can actually create an empty canvas. So to do that, just run that ggplot, then we pass our data set or data frame, right? You can see here we have just an empty canvas, but we want to tell ggplot, right? What variables do we want to use for X and Y? So that's what we specify here. So we specify that using the AES for aesthetic mappings. So the next thing we tell ggplot, we want to use display and highway, right? And we can check that display here is engine displacement in liters, and highway here is actually miles per gallon, right? So again, we just have an empty canvas, but at least it has some, it's ready to receive some data points, okay? So we use this plus now to add onto the different layers, right? So we can say, okay, we want to use the geom point, okay? Geom point just basically draws a scatter plot, right? So we do that, you can see we now represent the data points, okay, that corresponds to the y-axis and the x-axis for these two variables, okay? So, and that we managed to, draw our first layer, rather we managed to draw our data points on our empty canvas here, okay? All right, so we've done our first visualization, but let's go ahead and do a little bit of modification now. Remember, we can add color using these aesthetic mappings. We can have much more control. So let's go ahead and add some color. So in order to do that, basically here, we can just copy and paste that. So the only thing we can do here, so inside this geom object, right, geom point, we can just add this option, color equals to blue, right? So if I run that, you can see we already have something similar to this, okay? Or I can even change this to maybe red, okay? Alternatively, we can add, we can actually do a color based on the class. Remember, so we have our X and Y, right? And we can say we want to color that by the class, right? Remember here, the class here basically is the type of car, all right? So if we do that, if we run that, we can see that the class here is based on this. So it's color coded, right? For highway and displacement, right? And you can see here, according to the class here, you can see we have different colors representing these different classes, right? For the pickup here, you can see we have a higher displacement here and less MPG, right? And you can see a lot of our vehicles here, this subcompact type of class, have a higher mileage because they have a lower displacement here in terms of the engine size, right? All right. So again, just to kind of extend, you can change, you can play around with these different settings, right? But remember, we are not limited to this. We can also have all these different types of shapes we can actually leverage. You can see here, we can draw a scatter plot using geom point. We can use line, right, to do a line chart, smooth, to show some simple trends and approximation. We can do a bar chart using the bar, histogram, a polygon, a map, and things of that nature, okay? And in fact, we can go ahead and show that. So again, here, let's look at different shapes. So we just use the same thing. We are rendering a display and highway as our two variables, right? So here, All right, so we have here, so we want display here. So when we run that, we just have the default one, right? Black dots, highway display. Again, we can use the geom smooth, right? What that does, it just, draws just a line here, right? A line with a standard error with confidence intervals, right? Again, we can actually combine both, right? This is just a line by default. Can I use the lowest function? And we can see how to combine that, okay? We can also do this by drawing a bar chart. As you can see here, a bar chart just basically is just a frequency, the number of times, that class appears here, the number of vehicles in that class as a count, right? So ggplot automatically does that for you, right? And we can also do a histogram. You can see a histogram here. Basically, it just does a count for the same, all right? So we can also plot, both points and the smooth line. So we can do that by adding that as part of a layer. You can see here, notice how we're using class here to add a new layer, right? And you can see here, we're drawing a nice line here to show the relationship between highway and display, right? And this gray part here just shows the confidence. We can always deactivate that using the SE equals to false, right? As you can see, by default, it kind of uses this lowest function method. All right, so again, we've just reproduced those plots, and we can also change the different colors if we want. So for example, here, we can make it look a little bit more pleasing to the eye. You can see, we are saying here, let's have the red color here, right? So the color here for the line, right? Then we can change the color here for the data points, right? Now, again, here we can decide, okay, we don't want to see the, the confidence interval for our geom smooth. So in order to do that, we just pass this argument and say SE equals to false. SE just stands for the standard error. Geom plot kind of uses the predict function, to sort of give some standard error for the confidence interval, maybe at 95%, right? So basically here, without that, so if we run this, you can see how, let's just run that here. Okay, so you can see here we've done away with that confidence interval. So this is why we use this SE equals to false. And you can see now here, not only have we added the color for our class, we've also removed the confidence interval here. Okay, and we've actually added the geom point and the geom smooth using this plus sign. So we're building on our layer, right? We had an empty canvas. Then we, used aesthetic mappings to show the highway and display. Then now we also represented the data points on our canvas, and we tried to use this line using geom smooth, and we tried to color code. We actually color coded using this aesthetic mapping where we have control on the color. Okay, so ggplot does that automatically for us, right? Okay, as far as statistical transformation is concerned, so for example, let's say you wanted to just get, so let's see what you have here. So that's exactly what we have here, SE equals to false. So the other thing here, we wanted to, I need to run both here. So if I run that, we can see we actually have different lines for each of these class. Basically, this is, just one way of doing it, but it doesn't really convey what we want. So the best thing to do that on how to do that basically is to, use the color class at the top here at the global variable, right? So if we make it local here, it will be drawing, basically it will just draw every point, or rather it will be drawing every line for each of these data points, right? So the best point is just to specify this, to specify this at this level. So notice the difference here. So we have that, we have each line for every data point or for every class. But when we now, use aesthetic mapping for a geom point or geom object here, so we can say we want to color that by class, but we just want to draw one line. Okay, so when we do that, we have this nice geom smooth that applies for all the data points that shows, the class by their different colors. Okay. All right. So let's say, for example, we wanted to, have the frequency for the class. We can do that. We can achieve that by using the bar chart, right? But alternatively, we can also do a count using a dplyr function called count, where we count the MPG according to the class, right? That's what we are doing here, right? So we can reproduce this. As you can see here, we want to get the count for each of this, right? So in order to do that, basically we just say we use this function here, double column, basically means that we want to access this specific function that belongs to the dplyr package, right? And we're saying count for every MPG from each class, right? Remember. So we do that and then we store it into this new object, right? When we do that and we run that, we'll see we'll have a nice, summary here. So you can see for the two-seater class, we have, 5, our sample here is actually 5. For compact here, we have 47, vehicles that correspond to that, and so on and so forth. Okay. So that's just an example of a statistical transformation. All right, moving on, we can also use the geom bar here. Basically, that just does automatically for us when you say stat identity, automatically ggplot, sort of calculates that for us, right? Again, we can go ahead and run that. Basically, what this means is that we can add a statistical summary using function here. We can, use a mean here and a geom line, right? We can say we want to draw a line, right? And we can even say, oh, we want to change the line type from solid maybe to dashed. All these are just different features that allow us more control, right? We can even change the color here. Let's say change this color to maybe red. Okay. All right. Position adjustments. Okay. So there are 2 ways you can do this. You can either use dodge or fill. Okay. So basically here the dodge, sort of kind of fills, the values next to each other, right? And the fill here just does a percentage chart, right? So let's run this. Remember, this just allows us to change the position adjustment, right? And as you can see here, we have each of these bar chart next to each other based on, the drive here. And if we go here, the drive here basically stands for the type of drive terrain, right? If it's a front wheel drive, rear wheel drive, or 4-wheel drive, okay? So the dodge here just allows us to visualize that and can remember class and drive, right? Remember, we can also do this using fill, and fill just tries to superimpose each of that onto one bar chart according to a percentage, 100% being 1, right? We can see here, it's not very surprising. Actually, you can see subcompact here has both rear wheel drive, 4-wheel drive, and 4-wheel drive, right? Not very surprisingly, we have rear wheel drive here for sports car, for 2-seater, for example, a sports car. But I think it's very not very surprising here. Most pickups have a 4-wheel drive terrain, and here it's a bit surprising that we have a rear wheel drive, right, for an SUV, right? And a pickup, I would have expected to have a rear wheel drive here. Anyway, those are some of the things, what visualization can tell us. All right. All right. Other plots we can have, again, we can also have, violin empty cards is also another data set. You can just see it from here. So empty cars, basically it's a data set that comes with RStudio. So we can actually visualize that using ggplot. Okay, so we store it in an object called P, right? Create a canvas, and then we add a violin plot, right? So a violin plot here basically is just a blend of both the geom blocks plot and geom density plot, right? Just to show the continuous distribution of your data. Okay, there are many other plots, maybe we can review that in our next video. Just like you can also do a heat map, we can do a tile and things of that nature. Okay, right. The other component that we want us to look at is how to manage the scale, right? So here we have the color. We want to color the data by engine type. In order to do that, automatically we just say color equals to class, right? So we preserve our display here for X and our Y here for highway. Then we say color, let it be class, and then automatically we'll have something similar to this, right? So we have data points corresponding to the class, but at the same time showing us, the relationship between MPG and the displacement. And you can see they had the displacement here, the lower the highway mileage, right? You can see the lower the engine size here. Again, you can see high mileage, right? Except for this outlier here, it has a good balance, right? Even though it has a high engine displacement, but fairly does well around here. Okay. All right, so again, we can do the same by just running this piece of code. We can get the same thing. So here basically it kind of just uses the default. So it's the same thing as saying using this other scale, scale X continuous, scale Y continuous. All these are just the same as default, right? But we can decide to override some of these default. For example, here, if we wanted to say, okay, we want to increase the y-axis, the range here. So here we could just say, all right, so we can say, okay, limit equals to C, and we can provide, okay, our range here from 0 maybe to 60, right? We can run that. You can see here the scale has changed to 60, and we can do the same for X here, right? We can say, okay, maybe we want to just change that to maybe 10, right? When we run that, we can see but it doesn't look very well or very nice, right? But this just gives you a good idea of some of the things you can do, the scale X continuous and scale Y continuous, right? Sometimes we can use this to really exclude some outliers. So for example, if I wanted to remove this, I could just simply say here, okay, I want to maybe do up to maybe 6.8, right? And this one maybe to maybe 45. So if I do that, all right. So if I do that, you can see, I'm able to exclude some things, but, just use that with care. Sometimes you might do that for other different plots, but for now, we just want to display everything. So, but by default, we can just leave that as it were. Okay. All right. So again, here we can use the reverse here. So reverse here allows you to just do the reverse, right? We just use scale X reverse, scale Y reverse, and basically just shows the relationship, a linear relationship, right? The lower the mileage, right? The lower the city mileage as well, highway mileage and city mileage, right? And this kind of just, shows the reverse of relationship between the city mileage and high mileage. Okay, and we can actually reproduce that chart by that. Okay, so we just use a scale. We just use the scale reverse and X reverse and scale Y reverse. Okay. All right. So again, here, this is just another example of how to have much more control of your scale. So this is a good example. So let's run that. You can see here. So basically here, what we are doing here is that we want to represent this as a percentage. So we're saying, let's use this feature here. Okay, so the labels here would be in form of a percent, and that's why we have 60%, 80%. All right, so the labels here will have now additional label here in form of percent. Remember the previous one was just in form of 0 to 1, right? In fact, here when we're just doing the fill here, right? Remember, it was just from 0 to 1. So here we can further go ahead and have much more control on some of these options. Okay. So moving on, again, we can create some very nice plots using the color brewer. Again, in order to do that, you needed to have this package called R color brewer. So we can do that. It's called R color brewer. You can install that. So what it does, it has this palette. So if I if I just say display brewer all here, for example, you can see I can actually click on zoom here. You can see it has all these very nice color palettes, right? So here I can just choose set 3, set 2, set 1, just to do some nice color code, right? So, and that's why we are using it here. So we just use the same code we had before. Then we just use this scale color brewer, and we choose the palette. So in our case here, we can use set 2, or we can say maybe accent, right? So first of all, let's run this. You can see here, we have a nice color palette here. I could just go and say, okay, I want to use accent. I think that's what we had here. Let me close this. All right. So I have accent there. All right. So I have something similar to that, right? I could say, okay, maybe we want to use set 1, right? Have something like that. All right. Then moving on, we also have coordinate systems, right? This just allows us to, scale our ggplot and project that into different coordinates. There are different functions we can use here. We have the Cartesian, we can flip it, or we can use fixed or use polar, right? To show some circular charts, right? Or do a quick map. Okay, so let's look at a few of those. So basically here, just retain this as previous. The only thing we add here, we want to use the Cartesian, right? And when we run this, okay, so here basically we were actually specifying our x limits here, right? On our x-axis, we want it to start from 0 all the way to 5, right? So that's what it means. We have much more control of the Cartesian, right? Where we can specify the x and y values, right? Okay, which allows you to explode in, or you can actually zoom in or zoom out, right? Okay, so if I change this, for example, to 3, you can see it kind of just zooms in a little bit more, right? So if I change that to 10, maybe you can see it kind of zooms out, all right? Then we can also flip this. Maybe we can flip this, but we can also visualize that using a bar chart. Okay, so that now we have a bar chart, horizontal bar chart. All right, so this is the function that allows you to do that. Okay, and then lastly here, we can also use a box and whisker, right? So again, we retain this as previous. Then we say we use the jump box plot, right? Object, and say, okay, we can fill this with this color. Okay, Indian red, could be any other color you choose. Then we can say for labels, we have the class. For x-axis will be class, and for our y-axis will be fuel efficiency. And then we want to flip that, right? So if we do that, we'll have something similar to this, right? And we can again see we have quite a number of outlier. And I believe, when we talk about the remember when we talk about the SUV, where we had some, fuel efficiency here, you can see there are quite a number of data points here, right? Extreme values, right? In terms of fuel efficiency for compact, you can see there's one data point here that has a very high, fuel efficiency, all right? Again, with box plot, you can see the thick line is just the median, right? basically the mean, right? And then of course we have the Q1 and the Q3, and anything outside that is just an outline. Okay. And lastly here, we can force the units along X and Y axis using this coordinate fixed, right? So again, we have something similar to that. The only thing here, we can use the sequence here to just break our X continuous, meaning that we want to have much more control on how we scale our X, from 0 all the way to how our data is represented up to a maximum of 7. We want to have a break of by 1, right? We can have a ratio of 0.2, right? Okay, so that's just another way of using these scales, right? And when you vary this, you'll see how that kind of change. If I say 2, you can see how things change. It kind of gets squished, right? So that's what it means here. So I can just put a small ratio here, and at least you can see the data is well represented here. Then for facets, right? So with facets here, facets are just a way to group your data, into multiple different pieces. Okay, we call these subplots, right? In order to do this, we use this function called facet trap. Okay, we can achieve that either by using one categorical variable, or we can do for 2 categorical variables, right? So let's look at an example here. So for one categorical variable, again, we just copy that from the previous, and we just use this facet grid, and we're saying, okay, let's represent that in terms of different plots, represent the different classes. I think we had like 8 classes, right? So when we run that, should be able to have 1, 2, 3, 4, 5, 6, 7, around 7 classes. And I can actually zoom in to have a good representation here, right? Again, you can see we have a y-axis as highway, MPG, and displacement here for each of this class, right? So that's just a good representation, okay, using the facet grid, right? This just allows us to have free X. We don't have any limitations here. So it will just automatically do that by itself, right? Another method you can do this, again, we can say, okay, we want to specify the column, right? Use the calls. Then we want to specify the variable. Our variable here is class, right? If you remember here, MPG here, in fact, you can just say names, right? And then MPG. Okay, you can see we have this class over here. All right, so basically that's what we're using here. And if you recall, class here was actually character, categorical, right? So we can also represent, let's see here, year and cylinder, right? So we can also use 2 variables here. Let's see. Okay, so we use the tilde here. So if we wanted to represent more than 2 variables, right? So in our case here, you can see here, we're using highway and display, and we can use 2 variables here, right? Let's see what we have here. Year and cylinder, right? In fact, you can see here, we have the year, right? Okay. And also here we have the, according to the cylinder, right? 4, 5, 6, and 8. Then we have representation of our data in terms of year. I can actually zoom in and you can see a little bit more details here. Okay. All right. Okay. And how to add labels and notations, right? We can do this by, we just use this method. Okay. Again, we already have this code before, so we have we have the following option: title, subtitle, what we want to include for X, Y, and we can include the color, right? Okay, so once we have that, and remember we spread that by a comma. Once we're done, we close the parentheses, we add another plus there, and then we can also add this. This is just a caption. Might not need this now, but just to show you how this one looks like, right? So initially, this is how it looks like. You can see on our x-axis we have this. On our y-axis we have we have fuel efficiency per gallon, and notice the difference here. The top here we have the title. The title has automatically is formatted to have maybe just like in Word H1, right? And let's say for subtitle that's kind of H2, right? And then for the color, you can see here for the color we have the car type, right? Automatically we have the title for that. Okay, remember the color here basically denoted our class, right? Color coded for two-seater all the way to SUV, right? So if we added this now, you can see the caption here, right? You can use a caption by using geom text, and basically this just to tell us the position of in X and Y. So if I run that, you can see we can add some text, as a caption inside our plot. Okay. All right. So as we conclude here, we can see we can also use dplyr package. So we load the library package there. So let's say, for example, we wanted to view a table, all right, which has the best efficiency. We use the, remember, we use the pipe operator. So we just say, okay, let's have our data set. Then we want to group that by class. Then we want to filter that by the row number. And let's do that from the highest value to the lowest value, okay? And we want to extract, the best class or the best vehicles with the best efficiency, right? When we do that, again, we've already run that and we've stored it here. So we want to run that now. And we can actually view that. We can say view best in class. Again, we can see we have a nice table here. And this is just the best manufacturer, best model, right? Based on the class, right? And you can see here for compact, we can see the best here was Volkswagen New Beetle, right? With the highway MPG of 44. For compact, also we have Jetta, right? For two-seater, we have Corvette, right? And we can always go back to look at, the data here. And I believe when we look back here, we can see that for the two-seater here, rather for the, let's see, so we have displacement here, let's say for SUV, best mileage here. Okay, you can see the compact here, right? So we have compact here. Okay. So all these are just different data points. But again, here we can combine that with the dplyr to look at those. And you can actually see here for the subcompact here, right? The VW will be somewhere around here, right? 44. We can actually see the displacement here, actually 1.9 around 2 around here. So I believe this would be that data point here, right? For the New Beetle, right? We can see the next best here again for the, maybe for SUV. In fact, the two-seater here, 5-liter here, around 5 or 7, 5.7. A two-seater here will be somewhere around here, okay, with a highway of 26. So this could be it for the two-seater, and this will be the Chevrolet Corvette. Okay. All right. So those are just different ways, and we can actually plot that. All right, we can actually plot that, and we can see. We can actually show that by using labels, right? How we do that, we just use the geom label, right? We say new data is our new data frame, right? That we already created here, right? And we want to label by model, right? But the thing is, you can see we have an overlap of the labels, right? So in order to address this, we can remove that overlap by using a new package called ggplot2. we call that GG repel. I'll be GG repel, right? So you can install that. Okay, if you don't have it, you can actually install that. You can just say install the packages, right? GG repel. Actually, that will be GG repel. Okay, all right. So if you don't have that, you can install that. Once you install that, you can actually load that library like this. And in order to ensure that we disentangle these labels, we use this method that comes with ggRepel. We just say geom_text repel, and we, pass the argument, our new data set. Okay, and we want to say the option here is that we want to repel the labels by model, right? So we run that. You can see here where there was an overlap, automatically will try to reposition that automatically. Now we're able to visualize now the new beetle, the jetter, the covert, and we're able now to see, as opposed to just going to try and figure it out, right? We can actually give a label based on our filter, right? And this is the power of visualization in combination with some aspect of data wrangling. Okay. All right. We can also make this much nicer. In order to do that, we can also use a theme. We can add some labels, right? So in addition to that, what basically that means, we can add, fill class. We can add the color to blue. We can change the font face to be bold for the text, right? Segment color, and we can also add some labels. All right. For x-axis, engine power, y-axis to be fuel efficiency, right? And we can add a theme. All right. So when we run this, see, we have a nice representation for our chat now. It looks much better. We can change the color here if you will. I can change this maybe to red. Okay, you can change it to any other color that you deem fit. Right. I added this. So just to show you, you can do so much. There's something called GG themes, right? That's another package here. You can install that by clicking here. You can say GG themes, right? And you can install that. If not, you can just do the old-fashioned way here and comment that and install. So what GG theme does here, you can have, so if you go here, GG themes, right? You can see here, you can have quite a bit of, in fact, if I just do this theme economist, this is just an example of a theme that comes with GG themes. It just gives you a very nice way of visualizing your data. Okay, so let's just copy what we have here up to somewhere, just, the scatter plot with the labels, right? And the title, right? So the only layer we're going to add here is just the theme base, right? So how do I get this? With the underscore there, I have a list of options, right? And the good thing, it tells us where it comes from. So this is just the basic that comes from ggplot, right? We can choose this base, for example, right? And we can say, okay, we don't want to display the class. So we just say scale, color, economist, right? In fact, let's just go back here and use the economist, right? Okay, and we can say we don't want to display, the class, all right, the labels for the class. So once I run this, you can see we have a very nice, representation, right? So that's what we have here. So if I remove this option, right, basically we'll see we'll have a label here for class. We don't need that. So that's why we kind of just said, oh, okay, we just want to make that to be null. Okay. All right. Another theme I like using here a lot is the WSG SJ. That's the Wall Street Journal, right? So I can come here and select that. So I'll just go here, or I can just type there. Here it is. So I run that. We have that. Or I can actually use the Tuft, right? So if I type that, all these are just different themes that are available for you to use. They are very good and comes with the GG themes package. All right. So with that, that kind of wraps up our introduction to ggplot. So we've already covered different things all the way from these different components. So we've looked at, the basics of ggplot, aesthetic mappings, how to, specify geometric shapes, managing different scales, right? How to, use coordinate systems, facets, labels. And lastly here, one thing I just need to point out here is that ggplot, is best for producing data visualization in R, but most importantly for static visualization, right? But beyond that, there are other, libraries that can allow us to, perform exploratory analysis in an interactive manner. In order to do that, there are different libraries in R that can achieve this. One library is called ggvis, right? It's just similar to ggplot, but extends the usefulness of ggplot2, but allows you to have interactive visualizations, right? And another very popular library is called the plotly, right, which is also open source, but again, it's just very important, mostly used for producing interactive visualizations, right? And then lastly here we have HTML widgets, right, which kind of just leverages on JavaScript type of dynamic visualization. Okay. All right. So with that, we come to the end of our tutorial for ggplot. All right. Thank you.